Hi, this is part 3. You'll still be on the first page of your note sheet. And what we were just talking about is correlation. So correlations may be strong and weak and positive or negative. The strong should be strong or weak. Right here. Whoops. Statisticians, or people that do this for a living, express the degree of correlation between two sets of variables as a number between -1 and +1. And we're not going to do that. We're going to use words. So positive correlation means that as one variable increases, the other variable increases. Okay, so positive, both go up. Negative correlation means that as one variable increases, the other variable decreases. Okay, and you can think in terms of your slope for that. Rise over run. Remember that? No correlation means there's no relationship between the two variables. So basically you're fudging it, you're drawing a line anywhere and you can't really see anything between them. If it's strong, it means that the change in one variable sometimes means that there's a corresponding change in the other time, and that means it's very close. A weak means the change in one variable sometimes means that there may not be a corresponding change in the other. So sometimes it works and sometimes it doesn't. These types of correlation can be combined, so you can say a strong positive correlation, a weak negative correlation, to name only two of the variables there. Okay, on to my next page. So you can make predictions using these lines of best fit, and this is the purpose of using a line of best fit. You can actually extend your data just by drawing the line a little bit farther. Okay, so it's a prediction, so that means that it's not necessarily perfect. There are two methods, we talked about them before. Interpolating, which is calculating or estimating a value between known values, and extrapolating. Extrapolating is calculating or estimating a value by following a pattern and going beyond the values already known. And this can be in either direction, so it could be before the values and it could be after the values. So we're going to look at an example. Here's an example of this experiment on stretching, and we have masses and a spring, and here are the measurements that were obtained. So you can notice here that the first few masses, okay, so here's our masses, 20, 40, 60. There's a lovely little increase here, okay, so you'll see 14, 21, 28. Okay, so there's a pattern. That means that if you were extrapolating, or interpolating here, with 106, no, it's extrapolating, sorry, with 160 gram mass, the length of the spring could be extrapolated to be 50 plus 3, because you're going up pretty close to that. How does that work? Let's see. So if you look at that, 14 plus 7, 21 plus 7, 28 plus 7, 35 plus 7, 35 plus 6, sorry, 41 plus 5, 46 plus 4. So we seem to be taking away something here. So that would imply that it would be plus 3 here for this one, because you're going down 1 each time. But there's no certainty, right? It's in the early days it was 7, so maybe it goes back to that again. Who knows? And I'm going to save that now.